Hello everybody, welcome back to my Science is Magic YouTube page where I talk about the science and maths that fascinates me. This is the second week of videos of my Minecraft and Chill revision series, and we are going to be talking about physics today, or in this video. I've also uploaded a maths video and a chemistry video, so don't forget to check those out. And in the meantime, I'm going to chat about the theme today, which is mistakes, misunderstandings and musings for the GCSE courses that we're talking about. So grab a cup of tea, do whatever you've got to do, and maybe absorb some revision advice at the same time while I entertain myself with some Minecraft. So let's just wait for this to load. Alright, cool, we're in. So I've moved on, if you saw my other videos, from the end, and I'm going to start building a new base. And while the lag is bad, I apologise for that. So I've marked out what I want to do for my base, and I'm just gonna be building it in the background while I talk. So the first major mistake I would say that I made with physics, with GCSE physics, is that I thought that it was really hard. And it's kind of funny if you watch my chemistry video, and I'll be talking about chemistry. I thought chemistry was easy. I thought chemistry was the easy one of the two, and physics was hard. I found biology kind of both easy and challenging because it was just memorizing. And you know, that is a challenge, but it's not so intellectually challenging. I find biological concepts really intuitive and natural to understand, so I don't struggle so much with those. But physics I found really challenging, and chemistry I was like, God, this is the easy one. The absolute opposite was true. It was such a mistake. I got the first C I ever got, and oh no, I passed. What a poor me, you know. But I was getting A's and A stars and everything else, and I took my physics GCSE exam in year 9, so it wasn't a big deal. I was just going to take it again in year 10. It was kind of our school just letting us have a go in year 9. And so I took it again in year 10 and got B's, and took it again and got an A, and I just could not get, all of my other grades were A stars in science, and I couldn't get it in physics. And so this kind of gave me this misconception that it's the hard one of the three, right? But it just wasn't true. I wasn't applying myself and my studies to physics in the way that my brain needs to absorb physics, and that's a life lesson that I've taken on into my tutoring now. And kind of the opposite thing with chemistry, where I was like, oh, chemistry is really easy and intuitive and people could understand it. Chemistry is hard. Organic chemistry, I'll talk about that in the other video. Anyway, moving on. So one of the big mistakes I made in physics is that I thought I could get away with ignoring all of the content that was repeated in maths, because I found, you know, I spent lots of time studying that in maths. So I was like, this is fine, this is the easy, on easy mode. I'll just ignore it and focus on the stuff that I am finding hard in physics. No, that was an absolute mistake. Speed, distance, time graphs, all of the equations, you need to practice them. You need to practice them in the context of the questions, because while obviously if you've got the equation there and you're plugging numbers into an equation, that's pretty easy. But if you don't know how to read the exam question and how to apply that in an exam situation, you're going to find it quite challenging. And if you're making mistakes because you just haven't done the practice, no, mistake. I should not have done that. That should not have been my attitude. So that's kind of, I don't know. I don't know if anyone else will resonate or relate to that, but if you catch yourself kind of thinking along those lines of just dismissing entire subjects or subtopics because you're like, this is hard or this is easy, maybe question whether it actually is and whether you're missing a trick. But anyway. So the next thing is that I would regularly confuse the earth wire and the live wire in circuits in the 3-pin plug. And it's so, like, we're taught that stuff because we need to know You know, if an appliance goes wrong in our home and it, you know, can potentially catch fire and cause fires and things, we need to know this stuff. And I always found that kind of boring, that we needed to know about what goes on in those little white sockets. I didn't care. And again, that's my attitude, is if I find it boring, I will just dismiss it. So I didn't put in a lot of effort into learning it properly the first time. And so I always held it in my head that, oh, Earth is brown, Earth, dirt, you know, you can see. um, Dirt brown, Earth brown, live wire, life, grass green, life is green. And oh my god, it is the other way round. I literally got that wrong. And it wasn't until, you know, enough missed marks and lower grades that I was like, wait, I've written that off in my head and associated the two the wrong way round. Big mistake. The live wire is the brown wire. Just in case anyone else is similarly confused. So we want to think of Earth as the green one, the green and yellow stripy one, and the live wire is the brown one. And that's just, you know, an easy mistake to make. It's not the most important thing in the world, but one of the mistakes I used to make over and over again and didn't even know that I was getting it wrong. Anyway, another mistake that I would make, this is specifically an exam technique now, is that I would get really intimidated by the questions that I would read and think, oh, I don't know what to do. Because if I didn't immediately know what I was doing, again, I had this attitude of, well, I'm writing that off, I don't know how to do that, I can't do that. And just immediately that narrative would take over in my mind. And that was such a mistake, because if you can, it's kind of like if you've ever done any kind of sport, or, you know, a grueling task, or like longer distance running, or anything, just life, surviving, where you just have to push through that mental block and get to the other side, where you get that endorphin rush and you're like, oh, actually I can do this, I am doing this, I am nearly done with this thing that I'm doing. If you can push past that initial mental block in an exam, you're going to get yourself so many more marks. And you will also improve your problem solving skills and your self-confidence, because you'll see something that you think, oh, that immediately that's very challenging, I don't know what to do. And you'll realize that actually you can approach the problem in a different way, or a new way, or whatever it is. And that's going to be really beneficial for your, you know, your self-esteem and your confidence, particularly in the subject and with an exam situation. Because in an exam situation, we're in a state of heightened stress. And sorry, going into the nether, I've just realized I need more wood, and I've left all of my bits and bobs in a very far away base that I've been at recently in the desert, so I'm just going to make my way to gather a few supplies, and then I'll be back to building my base, my new shiny base with more resources that I have now, that I've accumulated. Anyway, working on this project, so you don't want to take that attitude of I can't do this and immediately write off a challenging problem in the exam. But we're in such a heightened state of stress in the exam that if you think about that and you feel an immediate spike of stress because of a question, you're going to struggle to remember things, and that makes it easier to make us want to avoid something, to avoid the problem, pretend it doesn't exist, ignore it, I don't want to do that. And what is important to remember is that the way to actually deal with that stress and combat that stress is to soothe yourself and relax, and just realizing I've gone the wrong way. You want to chill out, and then you'll be able to be more likely to remember things, to employ logic and your cognitive skills, and then you'll be able to solve the problem in the exam. So pushing past that big mistake, that I would write it off and avoid doing that, and I think that did cost me a lot of marks in a lot of different exams, and even through into my undergraduate exams in uni. It took me a very long time to learn this lesson, so there you go. Mistake I didn't realize it started very early on, and if I had caught it early on in my education, would have massively improved things. But anyway, computer's struggling with lag again. I have a potato laptop. It's probably about the processing speed of a few potatoes. Anyway, the next mistake I used to make all the time is, again, a very easy mistake to make, to confuse transverse and longitudinal waves. Now, transverse and longitudinal, I could remember the definition. I was like, oh, transverse, like when you're transgressing, you're crossing a line. So the transverse waves are the ones that go at 90 degrees, they go the other way, they go across the direction of travel. And longitudinal waves are long, they go long in the line of travel. So the definition's fine. Applying them or knowing what waves are which, I could not identify. So if you said to me, is a ripple in water longitudinal or transverse, I would, no matter what, always pick the wrong one. I was basically guessing 50-50. I don't know which. I do not know how to apply these definitions to the real life waves. And especially, I think I got it confused because of earthquakes. So there are two types of waves that propagate during an earthquake. And I think I used to confuse longitudinal and transverse waves with those two specific types of earthquake waves. And that's not necessarily true. That's not how that works. So a ripple in the water, the way to figure it out, the way to correct this mistake that I just never bothered to figure out, is to figure out, to really get into the definition, to really understand definition, not just to be able to quote it, but to understand. And that is that it's about the direction of propagation of the wave. So the ripple or the motion of a particle or whatever it is it going parallel or perpendicular to the direction of travel of the energy? So the wave is just, the wave is not a physical thing. It's just a vibration passing through different atoms of things that are next to each other. And there's this sort of invisible movement of a front of energy, the front of the vibration. And if that direction of travel is parallel or perpendicular to the direction that the actual molecules or atoms are vibrating in, that's how you tell whether it's transverse or longitudinal. So in a ripple of water, the little molecules of water, are they going up and down or side to side? And is that going to be parallel or perpendicular to the direction of wave travel? And the answer is that it's perpendicular. Because think the waves, literally, they lift up and down on the surface of the water, while the wave is propagating horizontally. And it's not that, I mean, you do get rolling, and it's more complicated than that, but just a straightforward, simple ripple. You've got up and down movement of the water. The one particle of water from the start of a ripple tank to the other end of the ripple tank, it's not moving that whole entire distance. It's just going up and down while the wave passes through it, right? So that's how you can tell. And similarly, no clue how color filters worked. Didn't think it was important, again, dismissed it. I think we're learning a lesson here. I think all of the mistakes I just made were just dismissing things that I didn't understand, which is very silly. I always used to, I don't know why, I just got confused whether color filters were, whether they, because you learn, kind of annoyingly, I mean, it makes sense, but you learn the two things at the same time, that you're either absorbing the color, and that's why it appears the other color, or you're letting colors pass through because it's the same color. And that just, I mean, obviously when I say it like that, I say it and it sounds very confusing because I just basically gave you a word salad. But I just used to confuse the concepts. So to set the record straight, a color filter is the same color as the wavelengths of light that it will allow to pass through it. So a blue filter will allow blue light to pass through and no others. So if you have a red object behind a blue filter, the red object will appear black through the filter because it's only reflecting red light, and the blue filter doesn't allow red light to pass through. So that's how they work, and that has lots of applications. But that's kind of, there was kind of a little theme, unexpected theme there in my physics mistakes. So moving on to misunderstandings, which is quite similar, but it's kind of like a slightly deeper level of confusion, let's say, rather than just like misremembering or confusing a fact or like, getting something wrong. This is more like no, I really didn't understand what was going on. And one of those things was the difference between resistance and how, like, what resistance actually was, but particularly how that would apply in the difference between parallel and I was going to say perpendicular then because I was just talking about waves, parallel and series circuits. The like you're not taught at GCSE. The syllabus doesn't go into detail about this. It's just kind of written off as an afterthought, and so teachers obviously don't prioritize like properly explaining it because it requires the understanding of concepts that you don't really learn until A level, and this just baffled me to a point where I just deeply misunderstood the concept of resistance until I got to A level, and I took the time to learn it properly, and my teachers explained it, and it was fine then. But for my GCSEs, I did not understand the concept of resistance at all. So I know that, or I knew that it was, it stops the current from being able to flow, and things get hot, and then there's friction. I understood that. I didn't understand what was going on with parallel and series circuits. Why in a parallel circuit do you seemingly get less resistance the more circuit you add? That's like, it's so counterintuitive to what you learn resistance is. Like, how can you add more circuit and then get a lower total resistance? It makes no sense because you add up the reciprocals for a parallel circuit, right? Whereas in series, you add more resistors, the resistance goes up. That makes sense. That's intuitive. And it's because you don't learn about current behavior, about electron behavior, about the probability, how everything to do with electrons, everything you think you know about electrons is probably not very accurate, because there's quantum effects going on with electrons. It's very cool, and you don't really learn about quantum stuff until you get to A level either, and then you can kind of go back to your GCSE foundational knowledge and be like, oh, I see how that on a bigger scale, this quantum effect leads to this more simplified effect that I learned and understood to be true at GCSE, and it's kind of, you deepen your understanding. I kind of wish that our learning went the other way around. I wish that we started with the most fundamental concept first and then built on that, rather than learning the simplified model first and then adding in complication. It just makes it harder for me to understand, but see, that's just me personally. It doesn't mean that everyone else would learn it that way. So I understand why it's not taught that way, but this just caused a deep misunderstanding for me with what resistance was, how circuits work, what electrons are doing, what is going on. I didn't know. So now you know too that it's to do with probability and following the path of least resistance, quite literally. And so if you offer lots of paths, you lower the resistance because there's lots of options, essentially. And that's not super complicated. I am simplifying it, but think of it like that. Whereas in a series circuit, you're just adding more things into the one path, right? Anyway, moving on. Forces is my next bullet point on my note here, and that is because, so this is kind of like one of the mistakes that I made, but I've put it under misunderstandings because I wrote forces off as boring. I was like, forces is the most boring thing. It's mechanics, it's just numbers, it's just a bit of maths, and all the rules are silly and boring, and there's nothing really interesting about them, and I'm sick of talking about cars and people on roller skates colliding, and it's all dull. But I didn't really appreciate, and we can fast forward here years into my master's year of uni. So how many years after GCSE would that have been? 2 years for A level and then 4. So 6 years later, in my master's year at uni, I was doing a volcanology and a fluid dynamics course, and those were the most exciting courses. I mean, aqueous geochemistry is my one true love, but oh my god, I chose volcanology and fluid dynamics as my options because the subjects just absolutely enthralled me. Learning about how pyroclastic flows move, learning about how plumes of ash move through the atmosphere. There was nothing more exciting in the world to me at that point in my life. And to my surprise, I found myself in those courses, in the practicals where we were doing practice questions, doing mechanics, doing the same foundational stuff with a bit of calculus thrown in on top that I learned at GCSE. And I was like, oh, I guess I'm actually really into forces and find it really interesting. It's just that it had to be applied to the correct situation. So if you, my sort of takeaway lesson from there is that if you find that you find a topic really boring, and I have so many examples of this. I dismissed the waves topic for the same reason, found it boring, and then I learned that to understand crystals properly and to do X-ray diffraction studies, which I'm now doing in my PhD, it's all about waves and light and how they behave, and that built on that foundational knowledge that I first learned at GCSE. So my takeaway message to you is, if there's a subject that you find really boring and you're not interested in it at all, have a read around, have a Google around, ask scientists who, are further along in their career and their education. Ask your teachers, ask your tutors, ask me, whatever. How is this stuff applied later in life? How is this foundation of learning applied to something more interesting later on? Because I'm finding it really boring and I would like to connect to the material in some other way. Because you would be very surprised what associations and where this stuff is actually used in real life and in just more objectively, I'm gonna call it volcanology is just objectively interesting. Nobody in the world finds volcanoes utterly boring. Surely that's true. Correct me if I'm wrong. But anyway, another fundamental misunderstanding I had was that the motor and generator effect, they were just completely the same in my mind. They are not the same. They are different expressions of a similar process, but in opposite directions. One is that movement will generate current, and the other is that current could generate movement. And the generation applies to the current, and the motor applies to the movement being generated. Easy way to clear that up. But I think we're going to call it there. I think me going to bed is a nice place to end this video. So I hope that was helpful anyway. Thank you for watching all the way to the end. Let me know if you want me to keep doing these videos. I'm enjoying chatting and Minecrafting and revising. Be kind to yourself, live your best magical life, and I will see you next time. Alright, yalla bye.